Okay, so when we're graphing sine and cosine functions, one really helpful thing to have is a basic reference. So I'm going to run through the basic reference that you guys will have to know. And this is crucial to your understanding the rest of what we're going to do with our graphing of sine and cosine functions by adjusting things as the amplitude and the period. We can change those by changing the x and the y values that we put in, but essentially we will always have this same shape. So all we're really interested in is where do the key points occur within any particular cycle. All right, so for sine of x, here's a picture of the y equals sine of x graph within one basic period from 0 to 2 pi along the x-axis. What has to happen is this. Our interval from 0 to 2 pi is divided evenly 4 ways. So exactly half of one interval, one period, in this case is pi. We divide each of these half intervals by half, and so directly between 0 and pi is pi over 2. And directly between pi and 2 pi is the value 3 pi over 2. These are the key values that we're going to use in our x table right here. Starting at 0, we work our way down, so we include pi over 2 as an x value, a key x value, pi, 3 pi over 2, 3 times pi over 2, that's 1.5 times pi, and then 2 pi. These, when I refer to key points along the x-axis, within one cycle of our basic function, these are our 5 key points, starting at 0 and ending at the period. For the y values, the y values are the y values that we get at each of these key points right here. So, for example, we know this graph passes through the point 0, 0. We know that at pi over 2, the value of sine is equal to positive 1. So this graph passes through pi over 2, 1. At pi, we're back to 0. At 3 pi over 2, we go down to a point here that's at negative 1 as compared to the y-axis. And then 0 again at 2 pi. Within one cycle, this is what we would see. If we repeated a second cycle, we go from 2 pi to 4 pi, or negative 2 pi to positive to 0 right here would be another interval. We've done that in the previous video, so these are the y values that we're going to adjust based on our amplitude, right? So we have positive, negative amplitude. Our amplitude is equal to 1. And so what's going to happen is that whatever our amplitude value, these are going to be reflected in these y values. All right, for cosine, what happens? Same deal. We divide up the curve into one full cycle at 2 pi along the x-axis. So 0 is our starting point here. We divide our interval in half. We say pi, that's halfway through the period. We go to pi over 2, halfway between the bottom half here, and 3 pi over 2 along our positive x-axis for one basic period. What happens at each of those points? Well, just like we did for cosine, we're going to get our key points at 0, pi over 2, pi, 3 pi over 2, and then 2 pi for one full period. For our y values, at x equals 0, y is equal to 1. At pi over 2, the cosine is equal to 0. At pi, the cosine is equal to negative 1 this time. At 3 pi over 2, we have 0 again. We pass through the x-axis. And then at 2 pi, we return to positive 1, at which point we would repeat this cycle over again. So from 2 pi to 4 pi, we'd have one more cycle, just like the one that we just showed. All right. So we are able to do this. Notice that the key points are the same for both sine and cosine. So that makes this a relatively easy task as far as the x values are concerned. The thing we have to keep straight are the values from our amplitude here for our y values, right? So we're going to have to use those to help us adjust amplitude. So that's going to be the first adjustment that we make. But keep this reference here in mind. We're going to use it over again when it comes to changing our amplitude. So that's in the next video.